Hi everyone. For my final project, I'll be presenting a one proportion z-test. My research question was simple but relevant, especially given my profession as a real estate agent. Do you currently own a house? I chose this topic because homeownership is central to the work that I do, and I wanted to understand the statistics behind what I see in the industry every day. The data for this project represents the proportion of Americans who currently own a home. For my significance level, I chose an alpha of 0.05, which is standard in statistical testing. As far as my sampling procedure, I used 3 different methods. I created a Facebook poll. I asked people at my church, and then at my brokerage when calling or answering phone calls of potential home buyers, I included the home ownership question in all phone conversations where I made contact. My target population was all Americans, and my sample included 72 randomly selected individuals. To avoid bias, I kept the Facebook poll open to people of all ages, genders, and backgrounds, and I asked my question the exact same way every time. This ensured clear questioning and no room for interpretation. So looking at the graph, we can see that of the 72 people that I asked, 46 people said yes, they owned a home, and 26 said no, they did not. This equates to 64% saying yes and 36% saying no. Now let's get into the numbers. According to the website census.gov, approximately 65% of the American population are homeowners. So our null hypothesis would be written as P equals 0.65, which would be interpreted as the proportion of Americans who currently own a house is 65%. Our alternative hypothesis would be written as P is less than 0.65, which is interpreted as the proportion of Americans who currently own a house is less than 65%. So let's check our conditions. Condition 1, is it random and independent? Yes, all of our data was gathered randomly, and each person is independent of the next. Condition 2, was it a large enough sample size? So the population has to be more than 10 times our sample. All Americans is more than 720 people, so that checks. Was it a big population? The rule is N times P is greater than 10, and N times 1 minus P is greater than or equal to 10. So, as we can see by the numbers, 46.8 is greater than or equal to 10, and 25.2 is greater than or equal than 10. So that checks. Next, I found my SE and my Z. So my SE was found by taking the square root of P times 1 minus P divided N, which is our sample, which gave us 0.0526. Our Z was found by taking P hat minus P divided by SE, which gave us negative 0.197, or approximately negative 0.20. Plugging the numbers into our calculator, we can deduce that our p-value is then 0.4217. So, our test statistic is negative 0.20, and our p-value is 0.4217, which we can see in the graph below. Being that our p-value is 0.4217, it is not less than alpha, which is 0.05. For this reason, we do not reject HO. My conclusion is written as follows. I do not reject HO. There is not statistically significant evidence to reject HO since our p-value is 0.4217. I conclude that the proportion of Americans who currently own a house is not less than 65%. Next, I found the confidence interval of 95% by doing the following. P hat plus or minus Z star times SE, which gave me a range of 0.5298 and 0.7502. We would write this as follows. I am 95% confident that the proportion of Americans who own a house is between 52.98% and 75.02%. I checked this in the calculator and the values are quite similar. So, this project taught me that statistical inference is more than just comparing numbers. It requires careful evaluation of the evidence. Even though my sample proportion was slightly below the historical 65% value, that difference wasn't statistically meaningful. Doing this test reminds me that assumptions, personal expectations, or what I see anecdotally in the real estate world shouldn't override systematic statistical procedures. This experience gave me a greater appreciation for how statistics help support objective, data-driven decision-making in real-world situations like homeownership. Thanks for listening.